Demo by Angelo of Majic brand Woodturning of precision lathe work using templates and tangents, recorded on phone cam at Lancaster, Pennsylvania by John Kelsey, February 2021.
So this one here, they take this out. See if I can do it. Okay, there you go. So then they'll take the shell, put it back in, cover it up, vanish this ball, vanish that ball, put this back in, make it all come back together. The vase consists of the lid, the ring,
that's the secret,
and the base, the shell and the solid. The first pieces I made a good wood turning fit for a box. And when I sent them to the guy that ordered them, he called me up and said, "These are no good. I'm sending them back. They're crap." I said, "What's the matter?" He said, "The fit is too tight." So these things actually have to fall apart in order for the magician to manipulate them in the fashion that they want. Now this is an original made by Floyd Thayer, who in his day, I'm going to say late 1800s, early 1900s, was his prime time. He was the consummate wood turner of his time. So everybody that collects anything wants to collect Floyd Thayer. They sing his praises about him being able to turn a ball without a template. The turning is pretty good. I mean, it's old and it's been hacked. I think the shell has been dropped and cracked, so they patched the crack, and that affected the fit. It doesn't fall apart. So the question for me was, do I leave it the way it is or do I fix it? And everybody that I talked to said, just leave it the way it is. You don't want to make it new. This, for me, you know, Frank Lloyd Wright, form follows function. So if it's a ball inside, it's going to be a ball outside. If it's an egg inside, it can be an egg outside. And you'll see this often in all of these old pieces, is that the three beads are all the same diameter, when in fact, if they're spherical, they're slightly different in diameter. This is what they call a passe set.
Okay.
And what it does, you got two different colored shells, and you say the magic words and they change places.
Let's do it again. Oh, that's very cool.
But you can see I got a little chip there on the foot, right there.
Yeah.
So I put a little Dutchman on it. So these guys will have to go to be painted black. These I like. I like the way these turned out. The black paint. Everybody said you should make black ones. I said, for me, the kick was the wood, and I wanted different kinds of wood. So to paint them black, I think I used cherry. And you can see that even these, now the pieces all fall apart. So this is actually a replica of Floyd Thayer's original vase in the size that he made it from the piece I copied. It's got this fancy finial, which is a pain in the patoot to turn because there's so many things going on. And I favor this kind of ball finial myself.
So how did you learn this?
I just figured it out. When we moved back to Rhode Island, I got a phone call. "Can you turn a Morrison pillbox?" I said, "Sure." I don't know what a Morrison pillbox is, but I'm sure I could turn it. So they sent me a sample, and I kept the sample around for about 6 months trying to figure out how do I even start with this thing. One Sunday afternoon, I finally sat down and just measured everything with a pair of calipers and a ruler. And then it dawned on me that I have to start with the solid in the shell first. Making the drawings made me think. So that's how I started. These are pillboxes. This one's here because it's broken. I dropped the shell. Pillboxes, makes them pillboxes because you can set the shell in the lid, set the shell in the bottom. There would be a solid ball here that you take out and vanish. You say your magic words and you put the ball back together. The advantage this had over the others is you could take out the entire assembled ball and not pass the assembled shell around, but pass the solid ball around to the audience so that they could see that you made another ball. This is another one of the same deal. This is Gonzalo Alves. Now this one has all of the parts, but this one is the rosewood is so hard and so slippery, it's hard to get it to stick. So the magicians look at this on my table and they said, "Oh, the ball doesn't stay." And I said, "Well, you could use a little bit of magician's wax to get it to stick." I could just give it a little huff. So these are ready to go. These will be the next ones up after I finish what's out in the shed. And they're all different woods, and for me the tickle was the different kinds of woods and not the actual shape or the turning or what they did afterwards. So I mean, there's just wood in here that's brown mallee burl, red mallee burl, pheasant wood from Hawaii, dyed and stabilized spalted maple, bokoti. Okay, so we're going to take out the templates. This is the shell that I turned yesterday. This is the template for the inside of this shell, so this is what we'll use. Starting here is a little 1/4 inch spindle gouge, 1/16 inch parting tool, a little 1/2 inch skew, generally used as a scraper, not hardly used as a skew, 1/8 inch parting tool. This is like a 32nd of an inch specially ground parting tool, French curve scraper, 3/8 spindle gouge, and Ashley Isles beating tool. Here I have the calipers that I use for sizing different parts of the vase when we turn the vase. So the 2-inch diameter outside of the vase, the flat of the parts that fit together for the tenons. Here's the tenons. This is the flat down at the bottom. It's the diameter of that little fillet right there. So this little diameter here. Okay, we're going to do a 2-inch solid ball. The first shape that we're going to turn is an octagon shape. This is half an octagon. And then we'll turn each of those facets into quarters and then take the corners off. It's cherry. It's a lot of sapwood. So now ideally this face should be square to that face. First thing to do is turn to the diameter. Okay, so there's one corner of the octagon, the other corner. And then down this side is that corner. So let's draw those in. So there's the center line. We'll put that up. And here's the other side of the ball. So now what we're going to do is, because the other corner of this facet is in the wood.
Yeah.
We're going to turn the tenon to that corner. In other words, this is half of the tenon, so we're going to double that dimension, which will be that dimension.
Right.
And we're going to turn down to that corner. Yeah. Okay, so there are the four equal pieces of that facet. And take it over the side. Mark the 4 equal pieces there. You can do the same on this side. At this point and at this point on the facets, it's the true diameter, the true radius. So that's what's nice about turning to tangents, is that you get there right away. Okay, so again, the other corner, this other corner on this, for this facet, is in the wood. So we're going to turn that tenon down by that much. So this dimension becomes the diameter of the tenon. Okay, so then we're going to turn the corners away. And take that corner, this corner, that corner, and that corner. And then I'm just going to use the skew as a negative rake scraper. It's a little high on the ends. Close enough. that's pretty good. It's a flat spot there. And you can see that there's a divot there. And I just carved that off by hand. So for the shell, the first thing we're going to do is drill a depth hole. And we're going to check it on the template. We're going to use the blue mark on the drill bit. So that's the first thing we're going to do.
Now, is that going to be the final depth, or are you shy of it by some known amount?
Yeah, it's shy by something.
But like a big something or a little something?
A tiny little something. So the next thing we're going to do is we're going to take the template and we're going to scribe the diameter of the shell. And we're going to make that a little bit tight. So it's like a 32nd or less smaller than the outside of that template. So that's the line I'm going to turn to. This is a 1/2 inch spindle gouge. I think this is a detail gouge, a long and strong. So I'm going to go in and make a back cut. Start with the hole between 12 o'clock and 2 o'clock. Rub the bevel in the opposite direction of what we're used to seeing. And we're just going to follow it out. So that's down to the depth, the hole that we drilled. So now to turn up this larger diameter, I've got to raise the tool rest because you saw that I was struggling to get it to ride the bevel when it was down a little bit lower. So now I'll come up and get that bigger diameter. The problem with this cut is that the hole is not hemispherical, it's more cone shaped. So at about 45 degrees in there, there's a flat. So we erred on the side of caution. We didn't take the whole cut. And we'll scrape that out with the French curve scraper. It's a negative rake scraper, and it's made from an old planer blade. And when I first started making these, because I thought I would need a scraper that traced every radius that I would need to turn, I had a perfect radius ground on them to match the radius that I was turning. So I had 4 scrapers for each vase. And what I figured out is that the closer I came to the true radius of that tool, the bigger the bite and the bigger the catch. So I ended up grinding them into a French curve scraper and using a template. Okay, so now I've gone to the diameter that we scribed with the dividers. Check it, it's still too tight. And that's almost just right. What, a 30-second more to go? So to me it looks like it's getting caught right here at the edge. Looks like it might be down to here. Might be down to there that it's too tight. I mean, fortunately on this piece I've got plenty of wood. If I need to go deeper to make it right, I could. But sometimes there's just barely enough wood to get the shell out. So I'll call that good. Check to see the ball fits. The ball doesn't fit because it doesn't fall out, you see? So that's gotta be able to fall out of that shell. These are some of the balls that I bought and returned and trued them up. You can see even there with that little ball, it's slightly out of round still. See it right there? So there it's still tight. If I turn it a little bit, it's loose. So I've got to get that to fit. So my guess is that at the 45-degree angle in there that I said before is where the ball is getting wedged, because I think the depth is okay, and I think the diameter out in the front is okay, but it's still getting caught up in there. So I'll take that, even though it's a little tight right there. It's not too bad. I gotta sand yet. Let's start with 180. Okay, so right in here, right at the very edge, there's a little bit of a touch. I have to turn it away because I couldn't sand it away. I'll go down to 120 on it. See if I can get rid of that touch. Not because it makes any difference to the magician, it just makes a difference to me. Let's sand up to 400 and call it good. Okay, so the finish I use is Def spray lacquer and rattle cans. Give it a little spritzing, and then using 4/0 steel wool and paste wax while the lacquer is still wet, and buff that in there. And everybody says, well, why do you put the wax on while it's still wet? The answer is, Sal Marino told me to. Okay, so we're just going to turn the outside of the shell to diameter. That's the depth of the hollow. Okay, so this is the template I'm going to use to mark where these facets are that I'm going to turn to approximate the outside diameter of the shell. So you can see there's the center line of the radius. This is a little flat spot that'll be included in the ring of the finished piece. So since we're turning to tangents, we're turning, if we expanded this thing into a full circle, we'd be turning an 8-sided figure or octagon, like a stop sign. I'll turn that diameter at the bottom of that facet. So I'll turn down to that point right there with the parting tool. So this is the corner I'm going to be turning away to make the octagon shape. So then if we take this facet and divide it up into 4 equal pieces, I first saw turning to tangents. Myron Curtis demonstrated that, I think in Louisville. So what I'm going to do is I'm going to turn this corner away and this corner, the other face, is inside the tenon. And I think this is called a hexadexahedron when you turn it to 16 sides. So there we've got 1/4 of a 16-sided polygon. And you can see that we're pretty close to round. So I'm just going to take these corners off and get to that point. So I sanded out the facets that are going to be too close to the chuck to sand. And since the outside of the shell will be painted, I'm not going to sand to too fine a grit. That's 180 grit. So we're pretty close, we're not right on. A little thick for me. I put a little chamfer on this and taper the edge so it appears to be thinner than it actually is. So we're going to put 2 beads for the ring. So that's the parting cut for the top of the ring. This will be the top of the vase. And that'll be the ring. Okay, so that's a 16th inch parting tool. That's the ring right there, yep. Just using the screw to turn it around. that's the lid. So I'm going to try to make the diameter of the tenons the same, so that whether you put the lid on with the ring or without the ring, it still fits the tenon. So now we're going to turn that shoulder on the ring. So I'm going from the outside of one side of the shell to the inside of the other side of the shell, so they got a little extra meat. Okay, so there's the shell diameter. So this diameter is 2 1/8 inches, which is actually an 1/8 inch bigger than this pattern. So I'm going to go ahead and turn that down to the diameter I measured for the tenons. Okay, you can see it's getting pretty close to where the mark is for the shell. So I'm going to leave it good and call it good for now. Into the diameter of the shell, as well as to set the depth on the ring. So there, you can see it's a little tight yet. That's it. It's a little tight, but by the time I sand it and fit the rest of it, it'll have to work. So now I'm going to use that little beading and parting tool to scribe where the bead is going to be. So that's the front part of the bead, and the back is going to be parted off flat. This is the rim that's going to hold the shell. Now we're going to make the little ledge in the ring that holds the shell in place. So I don't know if you can see that little ledge in there. Okay, right there, there's about 1/16 of an inch to keep the shell from going through the ring. Okay, so that's the tenon for the ring to sit on when we turn the little recess for the bottom of the ring. Okay, so that's the tenon that's going to fit in the bottom of that ring. that's all I'm going to do for that for now. So it's a little looser than I like, but it's okay. Okay, so what I want to do is I just want to turn the inside of the edge there to fit the ball through. That's good. Okay, next step. Fit the shell and the ball into the lid. Because the curve of the inside of this is roughly parallel to the outside, it's plenty easy to turn, but because you're shoving the shell up higher than the center of the outside, the tendency is to come through on the edge. So the bigger I can start on the outside, the easier it is to turn on that part. Alright, so the first thing I'm going to do is I'm going to true up this surface and then fit the ring into the lid. So I'm going to turn this a little tight so that I can sneak up on the fit. I want this fit pretty tight because in the final turning of the outside of the shape, all three pieces are going to be together between centers. And if they don't fit nicely, then it wobbles around, and got to use paper to tighten up the fit. Okay, so I'm using the corner of the tool to scrape the shoulder and not the cutting edge. In other words, I'm using this corner of the parting tool to scrape that shoulder. Okay, so that's a too tight a fit. It fits, but it's too tight. So now here's where you make it or break it. You either hit it or miss it. And they're really only dust cuts. It's not like taking a lot of material away. Okay, that's good. It's really good. Now we're going to drill a depth hole. So what I'm going to measure is the depth of the inside of the shell, which is there. I measured with the ring on, so I got to put the ring on. So we're down to about a 32nd. So I'll just take that 32nd out of the top there. Hopefully we got enough room left. Okay, so I'm deep enough, almost, but I'm close enough where I can take the difference out of the ring. a this ring is going to fit on that shoulder. So I got to take some of this off before I hollow it.
Yeah.
Good enough. I can take the rest off the ring. But you see, now I got a little bit of slop in there, which I don't like. I'm going to drill another depth hole, back hollow the base. There we go. Okay, so we got the shell, the ring, and the solid ball all nested together. Check the fit. Fit's good. So we're home. Going up one more grit to 600. So I'm going to go ahead and rough out this base a little bit before I turn it around, because the chucking between centers gets to be pretty tenuous. Easier to take as much wood away now as any other time. But on dark wood, it's easier to use a light pencil. These two lines represent this bird's beak right here. So before I turn down to that diameter, I want to check to see how far the hollow goes down. And it's about a quarter inch away. So the shoulder I just turned is that flat right there. So the voice in my head says if it looks right, it's wrong. If it looks wrong, it's right. I'd rather have it tight than do this, but this happens more often than not. Now the hard part. This template is made to fit that curve when this edge touches the outside of the beak and this edge touches the shoulder. So the center line needs to be always lined up there, and you can tell where the high points are and where they're not. That's also the diameter. Not a lot. That's weird. The bottom is the one that's out. I know there's enough meat in here. I just don't have the courage.
Well, why does it have to be made any smaller?
Well, I'm trying to fit the template to the curve.
Yeah, but what does it matter anymore?
Well, I mean, it just matters on how it looks.
Well, it's going to look great. The wood figure is going to detract from any off sphericality of it.
Oh, well, I agree, but that's not the point.
Okay. What is the point?
The point is to get it as close to you can as perfect. Got to make it hard. I don't know if there's a... I used to read my kids Shel Silverstein. There's no fun in easy sailing, doing anything that anyone can do. That's it for me. For me, that needs to be about 1/4 of an inch or a little less. Let's see what we got. We got almost 3/8 here. here and get this out of the way. So that beak right there needs to be 90 degrees or parallel with the ways of the lathe. And then go into a radius into that point. Three grooves on the bottom. So even if the magicians don't see a signature, if they see three grooves, they know it's me. Oh, look at that. We got a little tiny piece of sapling. Oh, that's so pretty. Yeah, this one will stay with me. Okay. Got the bottom done, except for the very underside. The ring is mostly done. The shell is done, and we were working on the lid. .7/16 diameter ball at the top. Okay, so I like this little spindle here, this little finial, to be about 1/16 of an inch underneath the ball. But I can't do that with wood that's highly figured or slightly punky. But this Coca-Cola will take it. Oh, forgot to sand out the bead. So I'll have to remount it on the other chuck and sand it out. My daughter calls that a coke nail, because I guess people who take cocaine sniff with the little finger, but it's really a fingernail gouge to clean out the grooves. Okay. Okay, the base, the solid ball, the ring, the shell, and the lid. This is what we filmed the first time. This is the boxwood piece, and you can see that this needs a bit of little work because the ring and the shells stay in the lid. That's not the way these work. These work by means of dumping out the shell and the ball at the same time and multiplying the ball. This is the Cocobolo piece that we turned, and this is the piece of sandalwood. This one I've been carrying around for ages, and yeah, I still smell